Okay, example 2, same type of problem, but it's a word problem. We got flying arrow leaving the village and traveling 20 miles in a heading of 20 degrees. So let's take a look at flying arrow. Here's the village here.
Wow.
Isn't that awesome? All right. A heading of 20 degrees, and he went 20 miles. Should make that bigger, but oh well. 20-degree angle, 20 miles. Again, measuring from 0 degrees counterclockwise when we're dealing with heading here. All right, so 20 miles, a heading of 20 degrees. From this point, which means he's here now, he travels 40 miles on a heading of 210 degrees. So notice 210 degrees, and he goes 40 miles.
Wow, he should have just started at the village and just gone down, right?
He probably should have. Should have started the village. The question is, how far from the village did he end up? So what they're asking us to find here specifically is this.
Right.
Then what's the resultant? Well, I mean, he had to meet somebody over here.
Oh.
They didn't specify that. He was on a hunting trip,
Oh, I thought his
and he
map
was meeting his
upside
buddy
down.
over here, and then all the deer and stuff were over there. So
I
that's
thought his map was upside down. Buddy just
They thought they were going to be that way, but then it turns out they went the other way.
yeah, exactly. Yeah, he had bad information. He got here, and his friend said, "Hey, the deer are way over there, 40 miles away. Let's start hiking." They get over there, and the deer beat him up because they're so tired after hiking. Anyway. But again, how far does the village get? So we're looking for this, the resultant, the end result of how far from the village is it at. And what we're looking for is some number of miles at some heading. Okay, so that's what we're looking for. Just looking at it, just from my eyeball view here, it looks to be about 20 miles, right?
Yeah.
Close. I mean, it's about the same length as that, 20-ish miles. It might be 19 point something, 20 point something, 25. I don't know. It's going to be near 20. And as far as an angle is concerned, if I'm measuring from here around to there, it's something between 180 and 270, right? I can see it's a third quadrant angle. So I should expect, looking at my stuff here, if I were to draw a y-axis in through that point, hopefully a vertical y-axis. There we go. There's my x-axis, there's my y-axis, my black resultant vector of both of these vector movements, right? Puts me in the third quadrant. I should expect a negative I value and a negative j value putting me in the third quadrant, right? So just looking at it just on the surface in the picture world here, I can kind of get an idea of what type of answer I should expect to get. Negative I and a negative j somewhere in the third quadrant, okay? The magnitude of this should be about the same as the magnitude of that just based on the picture. So again, this is a physics technique here. Draw the picture, use your protractor, and I actually measured those angles exactly, and I did use a scale, so that's pretty much drawn to scale. All right. Again, in math we don't use the picture. I just want you to see the picture to help you understand where things are coming from. But,
Whoa.
drag that over here. All right. You stay over that. All right. You stay over that out of the way. All right. So, looking at this problem, and if we're starting to deal with something on a heading of something. If we focus on that, 20 miles on a heading of 20 degrees, how far he traveled is the magnitude and the heading is the angle. And if you didn't know that, the degree symbol should let you know it's an angle. So 20 miles on a heading of 20 degrees in vector form looks like that. They're giving us the polar form, just not written with the little angle symbol on it. And then we've got 40 miles on a heading of 210 degrees, so we're going to add that to 40 miles on a heading of 210 degrees. This problem's the exact same technique as the last problem. We want to convert both of those to rectangular form, add the components together as like terms, then convert back to polar form. We should expect to get something along the lines of what this vector looks like. So if I go 20 cosine 20 and 20 sine 20, again I just type them both in immediately, and then I write down what I see. 18.79i and 6.84j. Just looking at this blue vector, 18.79 miles east and 6.84 miles north, that seems reasonable, right? He went further east than he went north, right? Looking at the red vector, or I guess green, the green vector, 40 cosine 210, 40 sine 210, we get negative 34.64 and negative 20. So 34.64 miles west and 20 miles south. That also seems pretty reasonable, right? Based on what we're looking at.
Indeed.
So once I get to component form, now I have the ability to add or subtract vectors based on sign. In this case, I'm subtracting in both cases. So if I do 18.79 minus 34.64, we get a negative 15.85i. And if I do 6.84 minus 20, I get 13.16, negative 13.16j. If I knew that much and I lived in the village, I'd be able to send somebody out to search for Flying Arrow right after the deers beat him up and he's sitting there. He'll tell some story about, yeah, he'll tell some story about how some rival gang was there and beat him up and it wasn't the deer.
The deer jumped him. They knew he was coming.
The deer ambushed him, yeah. They led him to that special point. But if I was in the village and somebody said, hey, go 15.85 miles west and 13.16 miles south, you should find Flying Arrow sitting right there. And we should be able to administer first aid. But that would get us in the right position, right? But notice, we're going west and south, we're going negative, negative, that takes me to the third quadrant, so we're in the right quadrant as far as what we're supposed to be getting out of this resultant. As far as the length of it, again, I've got to do my stuff to figure that out. So if I'm going to change back to polar form, r equals the square root of. And again, let me just reiterate this. You get positive numbers when you square things, you get positive numbers when you do absolute values. Don't write minus signs in steps 1 and 2 on these problems, okay? Just write down 15.85 squared plus 13.16 squared. Write it like that every time. Minus signs do not affect anything because squaring things makes things positive. If you put minuses in your work, you're going to end up messing up more often than not. So square root of 15.85 squared plus 13.16 squared in parentheses. So I can, again, I know exactly what I'm supposed to type in. I type in exactly that it equals, and it gives me exactly what I'm looking for, 20.60 miles. Okay. Which is what we were expecting, right? Something around 20. That's pretty much around 20 as far as I can see. Step 2, we want to find alpha, which is the inverse tangent. And again, the most common mistake we do is upside down. It's the second over the first every time. So the second, 13.16, over the first, 15.85. So, inverse tangent of 13.16 divided by 15.85 in parentheses equals, that comes out to 39.70 degrees. Okay, real quick, just to hopefully clear that mistake up, let me just show you real quick, going back to our picture. If I've got my vector, let's say in the third quadrant here, right? How do I measure alpha? From where to where?
0 to
From the vector
oh,
To the x-axis.
to the nearest x-axis. That's how I measure alpha, right? I'm trying to find alpha. Now let's take a look using just basic trigonometry here. If I were to draw in my right triangle created by this vector, right? There's my right angle right there in the corner. This side is the j side, right?
Mm-hmm.
So some number j, and this is some number I, right? Right? What side is that in relation to this acute angle? It's opposite adjacent hypotenuse. That's the opposite side, right? And this side is the adjacent side, right? And notice the opposite over the adjacent is the j number over the I number, right? And opposite over adjacent is tangent, right? So I know that tangent of alpha is going to equal the j number over the I number, right? The second over the first. So alpha is going to be the inverse tangent of that fraction. That's why it is what it is. All right? And again, that's the most common mistake. People do it upside down. But there's no reason to, because this represents the opposite, that represents the adjacent every time. And tangent is opposite over adjacent. So alpha is 39.70 degrees. So theta, as we can see, we're going left and down. That puts me in the third quadrant. In the third quadrant, theta is equal to 180 plus alpha. if you don't remember those facts, they're on your formula sheet under the coordinate conversion section. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. The quadrant 3 rule is 180 plus alpha, so theta in this case is going to be 219.70 degrees. So as far as the answer to the question, how far from the village did he end up? We would say 20.60 miles on a heading of 219.70 degrees.